Cipher. What is transposition cipher? It is the another type of cipher where the order of the alphabet in the plain text is rearranged to create the cipher text. The actual plain text alphabets are not replaced. Now let us understand transposition cipher means when the plain text is converted into cipher, this transposition cipher changes and rearranges the plain text to create the cipher text. So we have the technique, which is an encryption method, which is achieved by performing permutation over the plain text, mapping plain text into ciphertext using transposition technique, which is called as transposition cipher. Now let us see what are all the different types of transposition techniques we have. Now here in the transposition techniques, we have four types of transposition techniques. Number one is rail fence transposition, columnar transposition, and improved columnar transposition. So I have divided it into two parts, columnar transposition and improved columnar transposition. A fourth is the book cipher or running key cipher. Now let us understand one by one. What happens in rail fence cipher? The rail fence cipher is the simplest transposition cipher. Why it is called simplest? Because it is well understood by the users. Easily it is understandable. The step to obtain the ciphertext using these techniques are: the first step is the plain text is written as a sequence of diagonals. This is the first step. Second, then to obtain the ciphertext, the text is read as a sequence of rows. Okay, so to obtain the ciphertext, the text is read as a sequence of rows. So one by one means row by row we have to read it to get the ciphertext. This is the second step. To understand this in a better way, let us take an example so that you can easily understand. Okay, now in this example we have a plain text, meet me tomorrow. Okay, meet me tomorrow is the plain text. Now what we will do, we will write this plain text sequence wise in a diagonal form. Okay, as you can see below. So this is the line. Okay, we divide this meet me tomorrow in two rows, which is called rail fence. So assume that this is a fencing. So we divide this meet me tomorrow in fencing. Now you can see what happened. M, then next E, E, T. Meet is divided into two rows. Therefore, we are using the fencing and we are dividing the plain text. So this is called the rearrangement of the plain text. Okay. Then me, M is located in the first row. In the second row, you can see E. Tomorrow, T. T is written here. O in the next row. Again, M in first row. O in next row. R, R. O, W. So in this fashion, we divide our plain text. Okay. So now looking at this image, this example. Okay. So you would get it why it got named rail fence. Now you could have understood that why it is called rail fence, because we have divided it by using one of the fence and we are writing it into two rows. Okay, the plain text is divided into two rows, and when we obtain the cipher text, to get the ciphertext, we read row by row. Okay, that's what. If you see in the first row, MEMTMRO. So first ciphertext MEMTMRO. Thereafter ETEOORW. ETEOORW. This is how we can obtain the ciphertext in the rail fence. Coming to second technique, columnar transposition technique. So in columnar transposition technique, the cipher is more complex as compared to rail fence. The step to obtain ciphertext using these techniques are: the first step, plain text is written in the rectangular matrix of the initial defined size in a row by row pattern. So we need to define a rectangular matrix, 4 by 4 or 5 by 4 or 5 by 5. Okay, so initially defined size, and whatever the plain text is there, that is stored in a row by row pattern. Second step, to obtain the ciphertext and read the text written in a rectangular matrix column by column, but you have to permute the order of the column before reading it column by column. The obtained message is the ciphertext message. Let us understand by the example. Okay, the plain text is meet tomorrow. Now if you put this meet tomorrow in a rectangular predefined size, that is 4 into 3, okay, permuted column order is 3142. It should not exceed the number of columns. It means that when you write 3142, if you see the number of columns are 4, your number should not be 5 or 6. Okay, so it would be equals to the number of columns. So we have 4 columns, we can get 4 numbers max. Okay, permuted column order should not be 5 or 6, and whatever the plain text is there, that plain text should be stored in a row by row order. Okay, so meet TOMORROW. Okay, so now to obtain the ciphertext, we have to read the plain text column by column as the sequence of permuted column order. So we can read column by column as per the permuted column. First we need to read the E, then T, then M, then E. Okay, so in this fashion we can read one by one. Okay, so this is how you can obtain in the row. When it comes to the column order, so first column is number 1, this one. Okay, ordering is already given, permuted column order. Now EOR, after reading EOR, you should read TOW, then you can go for MTR, then EMO. This is how you can obtain the ciphertext. It is the advanced columnar transposition technique with multiple rounds. Okay, it is similar to the basic columnar technique, but it is introduced with an improvement. Improvement means you can perform the iteration. That is made possible in this third technique. Multiple rounds can be possible. That is not possible in the basic columnar technique. The basic columnar technique is performed over the plain text, but more than once. Okay, the step 1, the plain text is written in the rectangular of predetermined or predefined size of row by row, and thereafter to obtain the ciphertext, read the plain text in the rectangular column by column. Before reading the text in a rectangular column by column, permute the order of columns the same as in the basic columnar technique. What technique we have used in the earlier, the second technique, columnar transposition, the same technique should be used in the multiple rounds also, in the third technique also. To obtain the final cipher text, repeat the steps above multiple times. Okay, so you can perform it multiple times to obtain the final cipher text in the third technique. Let us have the example. Okay, so this is the plain text, meet tomorrow. Again, we have stored it in row by row. Okay, so meet, TOMORROW. Okay, now what happens? Cipher text round 1. It means when you perform the first round of the cipher text, okay, so you can get it MTR, EOR, EMOTOW. But what happens when you perform the other rounds, you can obtain the other results. Okay, so the obtained cipher text for round 2 is MOOTRTREOEMW. Okay, this is the way we can perform as many iterations as required. Okay, increasing the number of iteration increases the complexity of the technique. Now you can easily find out, compared to the first round, it is complex to obtain this cipher text in the second round. How it is obtained? Now you can see MOO, right? Thereafter TR, thereafter this T and this R. Okay, and next we moved to this one, EO, then EMW. This is the second iteration. So therefore they say that when you increase the as many as in iterations, okay, it also increases the complexity in the technique. But for multiple, as stated, for the multiple rounds, it is very beneficial and you can perform n number of iterations to obtain the cipher text at the end. The fourth technique is the book cipher or running key cipher. Okay, so the book cipher or running key cipher works on the basic principle of one-time pad cipher. In one-time pad cipher, the key is taken as long as the plain text and is discarded after the use every time a new key is taken for a new message. It means that whenever the key is required, this book cipher works on the basic principles of one-time pad cipher. Okay, one-time pad cipher, the key is taken as long as the plain text, means how much plain text is there, that much of key cipher will be there. Okay, and discards after the use. Whenever we discards the plain text, we discards the message, it discards the key also. Every time a new key is taken for a new message. Whenever we are going to send the new message, every time it takes the new key. Okay. Now let us have the steps for the book cipher or running key cipher. Step 1 says that convert the plain text in numeric form. Consider A is equals to 0, B is equals to 1, C is equals to 2, and dash dash Z is equals to 25. Okay, we have 26 alphabets, but as you can see, A is equals to 0. The numeric value for the A is considered as 0. Hence, the Z is considered as 25. Okay, coming to step 2, take an one-time pad or a key from any of the books and convert it in the numeric form also. but the key must be as long as the length of the plain text. Okay, it means that when you convert it into numerical form, how much is your plain text, that much will be the length of your key. Okay, key should not be less than the plain text. It should be the equals to the plain text. Step number 3 says, now add the numeric form of both the plain text and key. When you generate the numeric form for the plain text and key, okay, so add both the numbers, each plain text letter with the corresponding key text letter. If the addition of any plain text letter with corresponding key text letter is greater than 26, then subtract it with 26. Means third step says that when you have after adding the plain text number and your key text letter number, if it exceeds more than 26, then what you need to do, if it is even 26 also, you need to subtract with the 26. If it's assume that 35, so 35 should be subtracted by 26, means you will get the value of 9 for that particular uh, addition of the character. Okay, now I will show you how it works. Right, by seeing this you will clearly understand. The plain text is meet tomorrow, and the key taken from the book is an encryption. Now let us understand this numeric form plain text. Okay, now the plain text, M is the 13th character in alphabet. As we started, A is equals to 0. Now M becomes 12. Now M is taken 12 numeric value, E is taken 4, 4, T19, T19, 0, and O for 14, M for 12. Like this, we have taken the value for meet tomorrow. And the key value, the key must be converted into numeric form. So the key text is there, and encryption is the key text, and numeric conversion of this and encryption. As we stated in the steps number 3, every letter has the number. Okay, so in the step number 1, we said that convert the plain text in numeric form considering A is equals to 0. Now you can see A is equals to 0. Like this, every key text is converted into numeric form. Okay, now what we need to do, add the numeric form of plain text and key text. Okay, now we have generated these numeric values for the plain text and these numeric values for the key text. Now both should be added. Now 12, 0, 12, 0. We are keeping all the numeric value here for meet tomorrow and encryption. Okay, now why we said that your key text and plain text should be equal, because whenever you are having n number of character as your plain text, your key text should be equals to the plain text, because when you are adding the values, both should be added. Okay, now 12, 0, 12. Okay, 12, 0, 12, 4, 13, 17, 4, 4, 8, 19 and 13, it's 32. Now what happens when we obtain 32? As we stated in the step number 3, okay, you can go for the last line. If, okay, if the addition of any plain text letter with corresponding key text letter is greater than 26. Okay, 26, already we have 32 here, means it is greater than 26, right? then subtract it with 26. Now what we need to do, this 32 has to subtract with 26. When we subtract with 26, we get 6. Now you can see just here is the 6. Okay. 21. As usual, we are putting 21 here. 31. It is more than, means greater than 26. Now subtract by 26. Then we can obtain 5. So we kept 5. Okay. Then 36. Subtract by 26. We get the value 10. 29. Subtract by 26. 3. 36. Subtract by 26. 10. 25. As usual, 25. 28. Subtract by 26. Okay. Uh, it's 2 actually. It is showing 3. 35. 9. Right. So like this, if you subtract, you will be get new cipher text. Okay. So whatever the numbers you are obtaining here, okay, so 12, 17, 8, 6, whatever the alphabet correspond to that number should be your new cipher text. So this is how you can obtain this book cipher or running key cipher. Okay. So hope you understood this concept. So thank you for